Okay, YouTube, in our last video, we defined reference angles and, how to determine them when we have some angle in standard position, how we determine a reference angle. Recall that given any angle in standard position, we call this theta. We would say that its reference angle would just be the angle that's formed between the terminal side and the x-axis. So kind of like this leftover angle right here that we would get if we were to drop an altitude and make a triangle out of this. So with respect to finding the reference angle, in this video what we're going to do is we're going to confront what do we do when we have an angle that, say, maybe wraps around multiple times and maybe it stops right here. How would we find the reference angle, which by the way is just this leftover reference angle right here between the terminal side and the x-axis? But how would I find that if I had an angle that's greater than 360-degree rotation or greater than 2 pi radian rotation, or perhaps less than a negative 360-degree rotation or less than a negative 2 pi radian rotation? And our method here is going to be basically this. What we're going to do is we're just going to find some other angle that happens to be coterminal to the original angle and just use it instead, because I would tell you that looking at this diagram right here, try to keep this consistent, if I said that these two angles right here, these would be, say, different angles. This would be phi, and maybe this one up here is theta. But you can see that they both stop in the same place. And so if we were to find their reference angle, we can say that these two reference angles, those would be the same. So what we're going to do is this. We're going to find a positive angle. Alpha is what they're calling it here, but it's got to be less than 360 degrees or 2 pi that happens to be coterminal with a given angle. And then what we're going to do is we're just going to draw that angle and use that to determine what the reference angle of the initial angle would have been. So looking at 665, the idea here is that 665, we can envision that this would actually exceed 360 degrees. So what we're going to do is this. We're just going to take off increments of 360 degrees until we find a positive number that happens to be between 0 and 360. So we would say, subtracting these, what I notice is I get 305 right here, positive 305. And that is a number that happens to be less than 360 degrees, but it's also positive. So what we're going to do instead is we're going to go sketch a 305-degree angle, remembering that positive angles go counterclockwise, and knowing that this is a 270-degree rotation down here. I suppose that 305 would be 35 degrees beyond 270. So knowing this, we would say that this is my 305-degree angle here. We'd say, where's the reference angle? The reference angle would be this leftover angle right here between the x-axis and the terminal side of the angle. And so we'd say, well, in order to determine this, one way to do it is to acknowledge that this right here was 35. And because these two angles right here would have to make the entire fourth quadrant, they'd add up to 90, then we could say that 90 minus 35, which is 55, that would be the value of our reference angle. So we would say theta prime, or a reference angle for a 665-degree angle, is 55 degrees. So the same idea applies over here when we're looking at a 15 pi force rotation. As a matter of fact, recall that when we're talking about rotations, we say this is pi, and all the way around once is 2 pi. But if we were to change this to force, we would say this is like 4 pi force. That's 1 pi. And this would be like 8 pi fourths. That would be like 2 pi. The idea is that 15 pi force would be well over this 2 pi. So what we're going to do is we're going to take our 15 pi fourths and we're going to subtract off increments of 2 pi radians. In other words, I suppose we'll need to take our 2 pi radians and make this 2 pi over 1, which in turn, when we find a common denominator, we have 15 pi force minus 8 pi force, the same 8 pi force that we listed right up here on the diagram. We would be left behind with 7 pi force, and we know that 7 pi force, that is less than 2 pi, because 8 pi force would be exactly 2 pi. So we're going to go ahead and we're going to sketch an angle, except for we're going to sketch the coterminal angle. So 7 pi fourths, remember that this is 4 pi fourths, and here would be 8 pi fourths. And that every pi fourth radian measurement here, we got 1, 2, 3, 4, those are all 45-degree angles. So we have 5, 6, 7. 7 pi fourths would have started over here and rotated through 7 of these fourths of pi. And the reference angle then would just be this leftover pi force. So the nice thing about working in radians is it's really easy to determine reference angle. So we say pi force is our reference angle. Excuse me. So for this last example, interesting, we have a negative angle. And so what I'm going to do is we're going to take this angle here, negative 11 pi thirds, which is clearly exceeding negative 2 pi, because negative 2 pi, that'd be the same thing as negative 6 pi thirds. So we've gone over this. What we're going to do is we're just going to add on increments of 2 pi. And what we're going to have to do here is find a common denominator. So we'd say plus a positive 6 pi thirds. What I end up with is a negative 5 pi thirds. And the interesting thing here is that that negative 5 pi thirds, we can add another 2 pi onto it. So we get negative 5 pi thirds plus another 6 pi thirds, and what we end up with is pi thirds. So pi thirds would be the reference angle, or sorry, the coterminal angle for this given angle here. And so what we're going to do is we're just going to go sketch it. And a pi third is really just like a 60-degree angle. We'd say here's our pi third radian measurement. The neat thing about this is the angle between the terminal side and the x-axis, the reference angle, is the same thing as the initial angle. So any angle that terminates in the first quadrant, or at least any angle that is acute, will have the same angle as its reference angle. So we say this is pi thirds. Cheers.